Somewhere in a data center in China right now, there is a chip running at full power that, according to the rules written in Washington, should not even exist. Not a prototype, not a rumor. A working chip humming inside racks of servers. Training models Washington spent years trying to make impossible. For nearly a decade, the plan was simple. Control the chip, and you control the future. Cut off the silicon, and you cut off the ambition. That was the bet the United States placed, backed by billions of dollars and the full weight of its closest allies. They were wrong. Not because a lab in Shenzhen built something better. The monopoly was not broken by a better chip. It was broken by not needing one. If you want to understand how, stick around, hit like, and subscribe, because this story only gets stranger from here. For decades, the logic behind America's chip strategy was almost elegant in its simplicity. If you control the machines that make the most advanced semiconductors on Earth, you control who gets to build the future of artificial intelligence. And at the center of that strategy sits a single Dutch company most people have never heard of, ASML. Its extreme ultraviolet lithography machines, EUV for short, are the only tools on the planet capable of etching the smallest, most powerful chips into silicon. No EUV, no cutting-edge AI hardware. It really is that simple. And for years, the rule was absolute. ASML has never legally shipped a single one of these machines to China. Not one. That was the wall. Quiet, invisible, and until recently, considered unbreakable. Then, in June of 2026, something happened that should not have been possible under that rule. U.S. Commerce Secretary Howard Lutnick began privately pressing ASML executives with an uncomfortable question. Had one of their top-tier EUV systems somehow ended up inside China anyway? Not hypothetically. Not someday. Possibly already. The very officials who built the wall were now quietly asking whether it had a hole in it they had not noticed. And here's the part that makes the whole embargo story even messier. Washington's own policy was never a straight line. Just months earlier, in January of 2026, the United States reversed course entirely and approved the sale of advanced H200 chips directly to China. The same government tightening the noose with one hand was loosening it with the other. So before we get to how China is working around the wall, it is worth sitting with this. The people enforcing the embargo are not even sure it is holding. And the policy behind it has already contradicted itself once. That is not the story of an airtight blockade. That is the story of a wall built with cracks already showing, long before anyone outside started trying to break through it. While the world was busy watching whether ASML's machines were slipping through the cracks, a much quieter story was unfolding inside a research facility in Shanghai, one that mattered far more in the long run. At the Shanghai Institute of Optics and Fine Mechanics, a team of Chinese engineers had been working on something the export controls were specifically designed to prevent. Their own extreme ultraviolet lithography technology, built from scratch, without ASML, without the West, without permission. And here is the detail that turns this from a research footnote into a genuine plot twist. The team is reportedly led by a former ASML engineer, someone who once helped build the very machines China was banned from buying, now working to help China build its own. It is the kind of irony that would feel too on the nose in a movie script, except this one is real. What they produced was China's first laser plasma EUV light source platform, the foundational technology needed to eventually manufacture the most advanced chips on Earth, without relying on a single machine from the Netherlands. Chinese state media has described the scale of this effort in strikingly blunt terms, comparing it directly to the Manhattan Project. Not in destructive power, but in national urgency. A concentrated, all-in effort to solve a single technical problem that the rest of the world assumed only one country could solve. Now, before this starts sounding like China has already won the hardware race, it has not. Even by the most optimistic timelines coming out of Beijing itself, functional EUV production capability is not expected until 2030. That is years away. Years of catching up still left to do. So this is not the finish line. This is the slow fuse. A long-term bet on hardware independence that will take the rest of the decade to fully pay off. Which raises an obvious question. If the hardware fix is still years away, how is China already running 70% of its heavy industry on cutting-edge AI right now? The answer has almost nothing to do with chips at all. Here is where the entire embargo strategy starts to fall apart, and it has almost nothing to do with what is happening inside a lab. It has to do with a much simpler idea. If you cannot get better chips, stop needing them. That is exactly the bet Chinese tech companies made, and it is paying off faster than almost anyone in Washington expected. Alibaba built a model called Qwen. Huawei built one called Pangu. Neither company set out to compete head-to-head with the most powerful hardware on the planet. Instead, they engineered their models to run efficiently on the chips China already had access to. Not the best chips in the world, just the ones sitting in Chinese data centers right now today, sanctions and all. And the results are not small. By mid-2026, this software-first approach had reportedly been folded into roughly 70% of China's heavy industry. Chemical synthesis plants, real-time traffic management systems in major cities, the unglamorous, invisible infrastructure that keeps an economy running, all of it now touched by AI models built to squeeze more out of less. Here is why that matters more than it might sound. Advanced chips exist for one reason: raw compute. More transistors, more speed, more brute force to throw at a problem. But efficient software quietly erases part of that advantage from the other direction. If a less powerful chip, running smarter code, can do 80% of the job a top-tier chip does, the embargo stops being a wall and starts being a speed bump. This is not China trying to catch up to the West's AI stack. This is China building an entirely separate one. Self-contained, optimized for the hardware it can actually get, and increasingly indifferent to whatever restrictions Washington writes next. And none of this happened by accident. Behind Qwen, behind Pangu, behind the labs racing to build homegrown EUV, sits something much bigger, a national blueprint written at the highest levels of the Chinese government with the funding to match. On March 12, 2026, China's National People's Congress approved a document that rarely makes headlines outside the country but quietly shapes everything inside it: the 15th Five-Year Plan. And buried inside its hundreds of pages is a single number that tells you almost everything you need to know about where China is headed next. Research and development spending growing above 7% every single year through 2030. 7% compounding year after year is not a modest increase. It is a sustained, deliberate acceleration. The kind of commitment that only makes sense if you are planning for a very long fight, not a short one. But the more revealing detail is not the number. It is the ranking. Inside that plan, embodied intelligence and robotics were placed in the exact same strategic funding tier as nuclear fusion, quantum technology, brain-computer interfaces, and 6th-generation wireless networks. Think about that for a second. China is treating the race to build smarter machines with the same national urgency it treats the race to build a fusion reactor. Not a side project, not an experiment. A core pillar of the country's future, funded like one. And that ranking is not symbolic. It comes with money attached. Roughly $8.2 billion from China's National AI Industry Investment Fund becomes accessible specifically because of where robotics and AI sit on that list. Real capital flowing toward real labs, real companies, real infrastructure, because a government document decided this mattered as much as fusion. Here is the bigger picture this reveals. The chip race is not being fought company by company, lab by lab, in isolated pockets of innovation. It is being fought by an entire funding architecture, planned years in advance, coordinated from the top down. Every workaround we have talked about so far, the Shadow EUV lab, the efficient software stack, all of it sits inside this larger blueprint. And blueprints are one thing. What China does next with actual leverage is something else entirely. Now here is where this story stops being about chips and starts being about something China has controlled for decades without anyone fully noticing. Rare earths. On June 22, 2026, China's Ministry of Commerce blacklisted 10 American companies, a direct response to the Pentagon expanding its own list of Chinese military-linked entities weeks earlier. But buried inside that list of 10 was a detail almost too ironic to script. Two of the companies blacklisted were MP Materials and USA Rare Earth, the exact firms Washington itself had backed to build a domestic alternative to Chinese rare earth supply. China did not just retaliate. It targeted the one weakness America was actively trying to fix. 2 days later, on June 24th, Beijing went further. MOFCOM Announcement Number 26, taking effect July 1st, created a formal reporting and reward hotline for flagging export control violations. A quiet but significant shift from a licensing system that simply says no to an active enforcement regime that actively hunts for who is breaking the rules. Then on July 24th, the pressure crossed an ocean. MOFCOM Announcement Number 30 placed 14 European Union entities on a new watch list, including German defense giant Rheinmetall, retaliation for the European Union's own sanctions just 1 day earlier. And the scale of what this leverage actually means became clear on July 16th, when the International Energy Agency issued a warning that stopped a lot of procurement teams cold. Full implementation of China's rare earth export restrictions could put $6.5 trillion of downstream global production at risk every single year. Here's why that number is not an exaggeration. China controls roughly 80% of the world's gallium and around 60% of its germanium, two elements sitting quietly inside nearly every GPU and CPU on Earth. And the cost of protecting against all of this? The IEA estimates that stockpiling 11 high-risk minerals would cost the rest of the world only about $900 million a year. A rounding error against $6.5 trillion of exposure. But this is not a one-sided story, and it is worth saying plainly. An earlier wave of Chinese export controls from 2025 was suspended until November 10, 2026, after direct de-escalation between Washington and Beijing. This is not a straight climb toward confrontation. It oscillates. So think back to that chip humming in a Chinese data center. the one that should not exist. It exists because the monopoly was never broken by a better chip. It was broken by not needing one. Is this the smartest move of the decade or a time bomb? Neither side can defuse. Let me know below.